Let me introduce you to a slightly different notation for the partial derivative. In the case we've just been discussing, Q, output, is a function of capital and labor. What this means is for any given values of K and L, there will be a unique value of Q. You tell me what K and L are, and I'll plug into that function, out pops a value of Q, a unique value of Q. Okay. Now, one of the notations that we're familiar with is this. Partial Q, partial K, is the partial derivative of Q with respect to K. There's an alternative way of writing this which is convenient. Another way of writing this is just this. F, your function is F sub K. So let's just define F sub K to be the partial derivative output with respect to capital, or the partial derivative of this function with respect to capital. F is just equal to Q, so it's an alternative notation. It's very convenient. And following a similar procedure, partial Q, partial L could just be written F sub L. Okay. And this notation we will find very convenient. Now, if you want to evaluate F sub L and F sub K at specific values of K and L, then you could just do it like this. For example, if this were our function, then you could say, what is the value of F sub L when K is equal to 64 and L is equal to 100? And you would just write it that way. Okay, this is the value of F sub L when K is 64 and L is 100. And we just found that a minute ago. We just found that that was what, 0.4? Okay. And in a similar fashion, we evaluated the marginal product of capital when K was 64 and L is 100. And we found that to be 0.625. This notation, F sub K, F sub L, is going to be very convenient when we look at second derivatives and cross partial derivatives. For example, F sub LL, with two L's there, is the second derivative of the function with respect to L. So this will simply be the partial derivative of F sub L with respect to L. In a similar fashion, F sub KK is just partial F sub K, partial K. And we could also do this. F sub KL, this is called a cross partial derivative. This is just the partial derivative of F sub L with respect to K. Now, Chang defines F sub KL. The term that comes first is what you're differentiating with respect to. So the K comes first, so you're differentiating with respect to L. And in a similar fashion, F sub LK, if we were to reverse this, Diana, this is the partial derivative of F sub K with respect to L. Okay. At least that's the way Chang defines it. You could define it differently, but this is the way Chang defines these partial derivatives to be.